Everyone. Today we're going to wrap up Chapter 1 and discuss density. We're also going to go over a simulation that helps to understand density a little bit better. Density is the ratio of the mass of a sample of matter divided by the volume of the same sample. So we can express that as density is equal to the mass divided by the volume. Or we could simplify that and abbreviate each of those terms. So density is D, mass is M, and V is volume. I did have a little video here at the bottom, but it's not working, so don't worry about that for now. Now, we talked about how to measure mass before. So if we want to measure mass, we just use a balance. But how do we determine the volume of an object? One way is to use a ruler and figure out the length of the object, and then we can use an equation for volume to determine that object's volume. But what if we have an irregular shaped object? The way that we can determine volume is with something called a graduated cylinder. So what we do here is initially we fill the graduated cylinder with enough water that it will cover the object that we're interested in. So here we just have an initial volume of about 21 milliliters. And then we add the solid object. And then we measure the final volume in this graduated cylinder. So let's say this is about 25 milliliters. So now to find the volume of the object, that will be equal to the final volume minus the initial volume. So in this case, it would be 25 minus 21, which would be equal to 4 milliliters, and that would be the volume of our object. Now, there are different sets of units that we can use for density. For a liquid, we often use grams per milliliter as our units, and this is what's called a derived unit. So we're taking two different units and using them in the same measurement or the same calculated amount. So this would be considered derived. Now, for solids, we could also use grams per milliliter, but most often we're going to use grams per centimeter cubed. And what's really great about centimeters cubed and milliliters is they are exactly equal to each other. So 1 milliliter is equal to 1 centimeter cubed. So it doesn't necessarily matter if you use milliliters or centimeters cubed. But we most often use milliliters for liquids and centimeters cubed for solids. So let's do a calculation example. Let's say that we have a 20 milliliter sample of liquid, and we're going to put that into an empty beaker. And sometimes I like to draw pictures so I can kind of visualize what's going on. Okay, so we have 20.00 milliliters of liquid in this beaker. And then it looks like the mass of the beaker is equal to 31.447 grams. And then we're told that the beaker and contained liquid were weighed and had a mass of 55.891 grams. So the mass of the beaker and the liquid is equal to 55.891 grams. And we want to calculate the density of the liquid in grams per milliliter. So remember that density is equal to mass over volume. So we're already given the volume, which is 20 milliliters, so we don't have to worry about the volume in this case. But the mass, we have to figure out what the mass is from these given amounts. So it looks like we just have to subtract the mass of the beaker from the mass of the beaker plus the liquid, and that should give us the mass of the liquid on its own. So the density will equal 55.891 grams minus 31.447 grams. And then we're just going to divide that by the volume, which is 20 milliliters. So if you would like to try this on your own and calculate the density, you can pause the video. And then when you restart the video, we'll go over the answer together. Okay, so for the mass, you should have gotten a value of 24.444 grams. And then the volume stays the same. And when we plug that into a calculator, we should end up with 1.222, and then our units are grams per milliliter. Now, remember, you should still take significant figures into account. So in this problem, we had a subtraction problem in the numerator. So we took 55.891 and subtracted 31.447. And remember that when you're subtracting or adding two numbers, we care more about the number of decimal places. So when we did that subtraction problem, we ended up with a value that also had 3 decimal places. But now, in this second step, we're doing a division problem. So now we care about the number of significant figures for each value. So in the first value, we have 5 sig figs. And then in the denominator, our second value, the volume, we have 4 sig figs because each of the zeros are after a non-zero digit and after a decimal. And then the 0 right here is considered a buried 0. So that would also be considered significant. So because our least certain value has 4 sig figs, that means our final answer should also have 4 sig figs. All right, and then here's that solution slide if you need it for later. And now we're going to move on to a simulation for density. Okay, so this simulation for density is located on the University of Colorado website, and they have what are called PHET simulations, so P-H-E-T. And I'll post this particular simulation link on the Canvas website. It does require Flash in order to work, so if you have a newer computer, it might not work very well, but that's why I'm recording this video. And this simulation helps with visualizing density. So on the right-hand side, I've chosen same mass. And the simulation has given me 4 different cubes, all with the same mass. And then over here on the right, I have an Excel file, and I've set up some tables here. So initially, we're going to work on this same mass example, and we're going to figure out the mass, volume, and density for each of these different solid objects. And then we'll move on to a couple of other examples. So starting with this example here, we have, again, 4 different cubes, and they each have the same mass in kilograms. So I've put those masses here off to the right. But now let's figure out each of their volumes. So down below we have a pool of water, and the initial volume is 100 liters. So now if I put this red cube in the water, it sank to the bottom, and we can see that the change in volume was 1.25 liters. So I'm going to put that into my chart. So 1.25. And now let's remove that red cube, and we'll put in the green cube. So that green cube looked larger than the red cube, and that's verified by the fact that the volume of the green cube is 2.5 liters. Now let's do the same thing with the next largest cube, which is the blue one. Whoa, okay, so this blue one has a volume of 5 liters. Oh, looks like I put them out of order here. And now let's check the volume of the yellow cube. Oh, the volume of the yellow cube is also 5 liters. Interesting. Okay. The yellow cube looks bigger than the blue cube. Let's double check here. Yep, that's 5 liters. Okay. Maybe looks are deceiving. Okay, so now let's calculate the density of each of these objects in kilograms per liter. Now in Excel, what's really handy is you can use equations to do the work for you. So in density, I'm going to put an equal sign. And we know that density is equal to mass over volume. So I'm going to click on mass, which is in B3, so column B, row 3. And then I'm going to put a division sign. And then I'm going to click on volume, which is in C3. When I hit enter, I get a density of 4 kilograms per liter for the red cube. Now, what do we expect the next density to be? So for the green cube, do we expect the density to be greater than the red cube's density or less than the red cube's density? So the volume of the green cube is larger. It's 2.5 liters. And because volume is in the denominator of the density equation, we should expect that this density is less. So let's do that calculation. And we find that the density is 2 kilograms per liter, so it is less than the density of the red cube. So even though the red and green cubes have the same mass, their volumes are going to determine their relative densities. So if something has a larger volume, but the same mass, its density is going to be smaller. And you could think of that as its mass is spread out over a larger volume. so its density is going to be smaller. Now let's calculate the density for the yellow cube and the blue cube. Now they also have the same masses as the red and green cubes, and then their volumes are both 5 liters. So 5 over 5 would just be 1. Now we do expect, again, that their densities will be less because their volumes are larger. So in a way, you can think of density as inversely proportional to volume. So as the volume increases, the density decreases. Now let's go back to the simulation, and we're going to do our next example, which is same volume. So everything here has the same volume, but you'll notice that they have different masses. So let's just dunk the first cube in the water. So we can see that the change in volume was 4 liters. So I've already placed those values in the table off to the right here. So now we just have to plug in their masses, and then we'll calculate the densities. So the mass of the red cube is 2 kilograms. The mass of the green cube is 4 kilograms. The mass of the yellow cube is 8 kilograms, and the mass of the blue cube is 6 kilograms. So let's calculate the density of the red cube. So that's mass divided by volume. And we get a density of 0.5 kilograms per liter. So what do we expect to happen with the green cube? It has the same volume as the red cube, but its mass is twice as high. Do we expect the density to increase or decrease? So we should expect that the density of the green cube is going to increase relative to that of the red cube. And in fact, when we plug in these values, we get a value of 1, which is greater than the density of the red cube. Now we know that density is equal to mass divided by volume, and that tells us that density is directly related or directly proportional to the mass of an object. So if the mass of an object increases, the density will also increase as long as the volume is the same. So now let's calculate the densities for the yellow and blue cubes. Okay, so the yellow cube had the greatest mass, and we can see that it has the greatest density. And then the blue cube had a mass greater than the green and red cubes, and we can see that its density is greater than the green and red cubes. But the blue cube's mass was less than the yellow cube's mass, so its density was less than the yellow cube's density. All right, so now let's look at some mystery cubes. So we've got cubes A, B, C, D, and E. And we don't know their masses, and we don't know their volumes. Oh, and I forgot to add purple to my list here. So we need to go through and measure the masses of each of these different cubes. And then we also need to determine their volumes. And then we can calculate their densities. And for this particular problem, we can compare the densities of each object to some densities of actual solid objects. And then we can try to figure out what each object is. So do we have ice? Do we have aluminum? Do we have lead? So we'll figure that out. So let's start with the red cube, and we're going to measure its mass using this balance off to the side. And the mass is 3.1 kilograms. Now let's determine its volume by placing it in this water. Okay, and we can see that the change was 3.1 liters. All right, so that is a pretty easy calculation. We're going to take 3.1 and then divide that by 3.1. So we should get a density of 1. Okay, so I'm just going to put the red cube off to the side. So the next one is the green cube. Oops. E decided to jump in the water. So the green cube has a mass of 4.08 kilograms. And then its volume is 4.08 as well. Interesting. Okay, so this also has a density of 1. Okay, let's move on to the yellow cube. Whoa, the yellow cube has a mass of 65.14 kilograms. And its volume is 3.38. So let's calculate its density. So its density is 19.3 kilograms per liter. Okay. So now let's focus on the blue cube. Its mass is 0.64 kilograms. And its volume is 0.64. Okay, so its density is also 1. Super easy. And then let's do the last cube here. So we're going to measure the mass. And its mass is 3.53. And its volume is 1. Okay, so then the density of the purple cube is 3.53. So let's look at that table and figure out what each object is. So the red cube had a density of 1 kilogram per liter, so that should be water. And what's interesting is you'll notice that ice and water have different density values. So you've probably noticed that ice floats in water. And part of the reason that ice floats in water is it has a larger volume per mass than water. So ice has a smaller density than water. So the temperature of a substance will affect its density. Now the green cube also had a density of 1, so that was also water. The yellow cube had a density of 19.27. So if we look through this list, it looks like the yellow cube was gold because its density is also 19.3 kilograms per liter. Now the blue cube also had a density of 1, so that was also water. And then the purple cube had a density of 3.53 kilograms per liter. So if we go down the list, it looks like that cube was diamond. So scientists, if they have a substance and they don't know what it is, they can measure the density of that substance, kind of similar to what we just did, and they can match it to the density of known objects. Now, sometimes you'll have a mixture of two items, and that can complicate the determination or identification of a substance. But if you have a pure substance, you can use this method to identify it. Okay, so I hope that helped to understand density a little bit better. Remember that density of an object is proportional to the mass and inversely proportional to the volume. And then I will see you in the next video.